So welcome. So now we discuss carbon dioxide laser. So an Indian engineer C.K.N. Patel designed the CO2 laser. So we know in the case of atoms electrons can be excited to higher energy levels. The distribution of electrons in the cells and subcells define the electronic state of the molecules. For example, helium neon laser. So besides these electronic energy levels, the molecule can have the other energy levels also due to the rotation and vibrations of the molecule. So that means CO2. So they give rise to various rotational and vibrational energy levels. And the principle of this laser, the transition between these vibrational and rotational energy levels leads to the constructions of molecular gas laser. So here the nitrogen atoms are initially rise to excited state. The nitrogen atoms delivers the energy to CO2 atoms, which has the closest energy level to it. So then transition take place between the vibrational energy levels of the CO2 atoms, and hence the laser beam is emitted. So the molecular laser have two types of transition between vibrational states of the same electronic state, transition between the vibrational level of a different electronic state. So CO2 laser satisfies the first conditions, the laser transition between vibrational energy levels of the same electronic state. So the fundamentals of modes of vibrations of CO2 molecule. So there are three fundamental modes of vibration. So first one, symmetric stretching mode 100. So here the carbon atoms is stationary, and oxygen atoms oscillate or vibrate along the axis of the molecule. See the diagram. So it's simultaneously it approaches or departs with respect to the carbon atom. So the state of vibration is given by three integers m and q. So here 100, so which correspond to the degree of excitation. And symmetric stretching. So here all the three atoms will vibrate. So here the oxygen atoms vibrate in the opposite direction to the vibration direction of carbon atom, so which gives the quanta of frequency 001 and 002. And bending mode. So here the atoms will not be linear. So rather the atoms will vibrate perpendicular to the molecular axis. So this gives rise to two quanta of frequency represented by 010, 020. And constructions of CO2 laser, it consists of a discharge tube in which CO2 is taken along the nitrogen and helium gas with their pressure level of 0.33 is to 1 and 2.7 cm of Hc for CO2. So nitrogen and helium respectively. So nitrogen helps to increase the populations of atoms in the upper level of CO2. So while helium helps to depopulate the atoms in the lower energy level of CO2, and also to cool the discharge tube. So the discharge tube produced by DC excitation at the ends of the tube, sodium chloride or Brewster's windows are placed. So confocal silicon mirrors are coated with aluminum, or a metallic mirror gold is employed for proper reflection, which form the resonant cavity. So the output power of can be increased by increasing the diameter of the tube. And working of CO2 laser, the discharge is passed through the tube first. The nitrogen atoms are raised to excited state. So the excited N2 atom undergo resonant energy transfer with the CO2 atoms, and rises CO2 to excited state due to the closer energy level. of CO2 and nitrogen. So when transition takes place between 001 to 100, the laser of wavelength 10.6 micrometer is emitted. So similarly, when transition takes place between 001 and 0 to 0, so laser beam of laser 9.6 micrometer emitted. And applications of CO2 laser. This laser has applications in a medical field such as neurosurgery, microsurgery, treatment of liver, lungs, and also the borderless operations. So it is widely used in open air communication. This laser also have a wide applications over military field. So thank you. See you in next video.